Hey everyone, welcome to the channel. Today, we're combining Python programming with probability theory to simulate the classic board game Monopoly. We'll be analyzing the distribution of landing frequencies over 10,000 turns using a statistical model. This helps us explore how the randomness of dice rolls and card draws actually plays out over many iterations. So let's dive in. We're running a Monte Carlo style simulation where one player takes 10,000 turns in Monopoly. Every move is driven by the outcome of two six-sided dice, which follows a discrete probability distribution, with seven being the most likely sum. Additionally, we introduce randomness through shuffle chance and community chess decks, which alter position and skew the expected landing probabilities. Over time, we use this simulation to generate a frequency distribution and compare it against a uniform distribution using a chi-square goodness of fit test. So here's how the simulation set up. We simulate a single player taking 10,000 turns. Every move is recorded, and we account for real Monopoly rules, rolling doubles, landing on jail, drawing cards, and so on. The data we collect will show us landing frequencies. So running the simulation starts with the main function. The main function controls everything. It starts by setting up the chance in community chess decks and shuffling them. Then it runs the simulation by calling a sample function that plays out 10,000 turns. Finally, it calculates how often each square was landed on, compares it to expected values, and performs a chi-square test to check if the variation is significant. This is where the player's movement is simulated. Each turn, we roll two dice and move the player forward. If they roll double, they get another turn, just like the real game. But if they roll three doubles in a row, they go to jail. The function also checks for special squares like chance, community chess, and go to jail. Chance and community chess cards are handled with two separate functions. When a player lands on a card square, the deck is cycled like a real game. The drawn card is moved to the back. The cards cause different moves like go to jail, move to utility, or go back three spaces. This adds randomness and realism to the simulation. After simulating the turns, we collect the data using a couple of functions. First, we count how many times each square was landed on. Then we calculate averages and standard deviations. Finally, we visualize everything using a histogram so we can easily see which squares are the most popular. Here's the graph the simulation produces. Notice how some squares like jail or squares right after jail are hit more frequently. That's because players are often sent to jail or passing by it after getting out. Orange properties, for example, are commonly landed on and are often good investment in the real game. So, what did we find out? Monopoly might feel random, but some positions are clearly more likely to be landed on than others. This explains why some properties like Illinois Avenue or the railroads are strong buys. The simulation backs up what expert players have observed for years. This project is just the beginning. We can improve it by adding more players, simulating buying and trading, or even comparing different property buying strategies. There's a lot of potential to expand the model and maybe even build a bot that plays strategically. So that's all from my end. Thanks for watching. If you like the video, please give it a thumbs up and consider subscribing for more content like this. As always, the code is in the description of the YouTube video, so please go to check it out. Thank you.